Okay, let's just continue simplifying the imaginary number and writing number 4 here as a complex number with a real part. The number 2 is a real part. And let's simplify the square root of a negative 28. So, you know what? Two numbers multiply to be 28. One of them has to be in the list of perfect squares. So I'm thinking 4 times 7. I'm going to make the 4 negative because I don't have to show any work. I've proven this to myself 100 times over, that the square root of a negative 4 is 2, and then don't forget the j. Square root of 7 has to stay underneath because it's not a perfect square. I take this term and I put it, and I'm going to go ahead and erase this. I put it right after this minus sign, and I have now simplified this complex number. Again, this is the real part. This is called the imaginary part. This particular number just has an imaginary part, so I'm just taking you one more time through the process. The two numbers that I think of are not 6 and 3 that multiply to be 18. They are 9 and 2. Because 9 is a perfect square, I can take the square root of it. I'm going to put the negative sign with the 9 so that I can pull that out from under and call that 3j, then times the square root of 2. Okay, the next piece is going to be a piece where many people make an error. You must, when you have an imaginary number, write it in terms of j first. Now, this is kind of odd the way I did this, so I'm actually going to switch over here, but the negative 4 underneath the radical is a negative 1 times 4, and j squared is defined as a negative 1. So that's what I've done right here. But I think it's a bit easier if I think of the square root of a negative 4 as just 2j. And then that needs to be squared. So right here, that needs to be squared. And 2j times 2j, that's just algebra, is this 4j squared. But that, I want to remind you, go back a minute, we defined j as the square root of a negative 1. And then we squared both sides, and therefore j squared is just a negative 1. So you're going to be seeing me take this j squared term, thinking of it here as 4 times a negative 1, therefore calling my answer a negative 4. So sometimes I'm just going to drop the j squared term and change the sign of the coefficient. You'll see here in the next one. Bottom line, this is what some people do think they can do. They think they can write this out twice and not think in terms of j. They think they can multiply the number under the radicals together. Negative 4 times a negative 4 is a positive 16. And then get the square root of 16 and find that that's equal to positive 4, not a negative 4. And the answer really is a negative 4. So when you have the square root of a negative number, you have to write it in terms of j. So let's simplify these expressions. So what this one means is the square root of a negative 9 times the square root of a negative 9. That's what that means, which is 3j times 3j, which algebraically is 3 times 3 is 9, j times j is j squared, and then j squared is going to be replaced with a negative 1, so 9 times a negative 1 is a negative 9. When we go further on in this unit, when I see 9j squared, I'm just going to jump to the minus 9. So again, this doesn't change. It's a square root of a negative 81 times the square root of a negative 81. I write it out so that you just don't forget that that's 9j times 9j, which is 81j squared. And again, this is kind of what I mean I'll do. I'll cross this off and call it a negative 1. So my answer is a negative 81. So interesting, would you notice in this case that my answer is what's under the radical? So the answer for this one should be a negative 0.6, going through that same process. Let's keep going. So if the numbers are not squared, then what I would have you do is I would have you think of, actually I'm going to write it right here. I'm going to think of the square root of a negative 2 as the square root of a negative 1 times the square root of 2. That square root of a negative 1 is j. I can't do anything with the 2. So when there's a number under the radical that's not a perfect square and there's a minus sign right here, I will in the future just pull it out and call it j, and then the number under the radical would be the positive value. The square root of a negative 8, though, is the square root of a negative 4 times the square root of a times the square root of 2. The square root of negative 4 is 2j times that square root of 2. Now, this is all multiplication. See, there was a dot here. Multiplication can be done in any order. So I'm going to take the j and multiply it by the 2j, and I'm going to get 2j squared. And then I'm going to take the square root of 2 and multiply it by the square root of 2, which is going to give me the square root of 4, which is 2. So what I have is 2j squared times 2, which is 4j squared. Right here, 2 times 2 is 4. J squared is a negative 1, so I have a negative 4 for that answer. So, commonly somebody might think that that's supposed to be the square root of a positive 16 because a negative 2 times a negative 8 is a positive 16. Not the case. All right. So finally, this next one, there is not going to be any perfect squares in this, so I'll just pull the j out from under the radical, and then there will just be a 3. A j out from under the radical, there will just be a 7. These can be multiplied together. I'm going to put them in front and call them j squared. And then these can be multiplied together. And 3 times 7 is 21. They're under a radical. It's not a perfect square. There's nothing you can do with it. Out in front of this is a j squared, so that's equal to a negative 1 times the square root of 21. Or many people would just write that with a minus sign in front of the square root of 21. Okay, let's talk about powers of j because they are repetitive after the first 4 powers. So let's go ahead and do that, and we'll finish this segment in a few minutes. So first of all, j is equal to the square root of a negative 1. So we then squared both sides and said j squared is a negative 1. Well, I wonder what j to the third power is, and this is where I need to know my rules for exponents. I'm going to break j to the third into j to the second times j to the first. Well, j to the second is a negative 1, so this right here I'm going to replace with a negative 1. So I have a negative 1 times j. Or we often just call j to the third, again, we often call j to the third a negative j. J to the fourth, I like to think of as j squared times j squared, because remember, you add your exponents. 2 plus 2 is 4. But way back here, j squared is a negative 1. And so we have here a negative 1 times a negative 1 is a positive 1. And from here, the pattern will repeat. But what I want you to know is that I just love, I'm bringing a couple colors into my palette so I can use them. I just love j to the second because it's a nice number, negative 1, and I love j to the fourth because it's equal to 1. So let's come on over here and talk about j to the fifth. So what I do when I develop j to the fifth is I write it in terms of j to the fourth because I love j to the fourth. Joking, because j to the fourth is just number 1. So j to the fifth, this is a puzzle. It's like a Sudoku puzzle. If you add these exponents, you get j to the fifth, but j to the fourth is 1, and 1 times j is j. And I'm back to where I started. I started with j to the first, and j to the fifth is also j to the first. J to the sixth would be j to the fourth times j to the second, which is 1 times j squared, and 1 times a negative 1 is a negative 1. So j to the second is the same as j to the sixth. Keep going. J to the third. I'll go with, let's go with j to the fourth times, oops, I'm sorry, this is supposed to be j to the seventh. J to the fourth times j to the third. So, that just makes you back to 1 times j to the third, which is right here, and j to the third is a negative j, so now here I am, j to the third is j to the seventh. And finally, j to the eighth, I like to think of as j to the fourth times j to the fourth because I love j to the fourth because it's 1 times 1 is 1, and I think I've run out of colors here, so I'm just going to use this right here. J to the fourth is the same as j to the fourth, which is 1, is the same as j to the eighth, which is 1. So would you notice that the pattern is, and I'm going to see if I can scroll over here, because it's in patterns of 4. The answers will be j, negative 1, negative j, and 1. So do you see this? J, negative 1, negative j, and 1. J, negative 1, negative j, 1. J, negative 1, negative j, 1. If you want to memorize it. I don't. I like to develop it. But anything that's got an exponent of 4, so j to the 8th, is j to the 4th times j to the 4th, which is 1 times 1, which is 1. I hope you won't make me write this out, but j to the 24th is j to the 4th times 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 j to the 4th, because when I add up all those 4s, 6 of them, I get 24. So it's 1 times 1 times 1 times 1 times 1 times 1. And I'm trying to exaggerate so that you remember anything that's divisible by 4, if you can take your calculator and take 104 and divide it by 4 evenly, which you can, you get 26, then your answer is 1. And therefore, let's finish this right here. So j to the 105th, I'm going to write it as j to the 104th times j to the 1st. So again, it's a puzzle. Really, it's a game. And I know j to the 104th is the number 1 times that j to the 1st. So I have simplified j to the 105th to be called just j. Let's pause here and we'll come back and do some more.